In section 11.3, we're going to be proving that lines are parallel. Look at Theorem 9 at the bottom of page 670. Right above that, it says essential understanding. You can use certain angle pairs to decide whether two lines are parallel. So in Theorem 9, it's the converse of the corresponding angles theorem. The corresponding angles theorem says if you have two parallel lines, then the corresponding angles are congruent. This is the opposite of that. If you have two lines and a transversal, and your corresponding angles are congruent, then the lines are parallel. So if you know that corresponding angles are congruent, you can prove that the two lines are parallel. So let's look at the got it problem, identifying parallel lines, on the top of page 671. In the got it, it says, which lines are parallel if angle 6 is congruent to angle 7? Justify your answer. Well, you'll notice that you have four lines. You have line L, and you have line M. 6 and 7 are formed by the transversal B. So if angle 6 and angle 7 are congruent, then we know that line L is parallel to line M. So line L and line M are parallel. Why? We have to justify it. The reason is because it's by the converse of corresponding angles theorem. So because angle 6 and angle 7 are congruent, then we know lines L and lines M are parallel. At the bottom of page 671, we have Theorem 10. This is very similar to Theorem 9. Theorem 10 is the converse of the alternate interior angles theorem. This one states that if angle 4 and angle 6, which are alternate interior angles, if you have two alternate interior angles that are congruent, then the two lines are parallel. So in this case, angle 4 and angle 6 are congruent, therefore we know that lines L and M are parallel because of the converse of the alternate interior angles theorem. On the top of page 672, we have two more theorems. Theorem 11 is the converse of the same side interior angles postulate. Here it says that if two lines and a transversal form same side interior angles that are supplementary, then the lines are parallel. Once again, if the measure of angle 3 plus the measure of angle 6 is 180, we know that lines L and M are parallel. Theorem 12 is the alternate exterior angle, the converse of that theorem. If two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. It's the opposite of what you've learned the last two sections, where now we do the converse to prove that the lines are parallel. Problem 2 talks about flow proofs, which we don't need to know those right now, so we're going to skip over flow proofs. But I want you to go to problem 3 right now. Problem 3 talks about determining whether lines are parallel. Above that it says, the four theorems you have just learned provide you with four ways to determine if two lines are parallel. So let's go to problem 3, number 4. It says two workers paint lines for angled parking spaces. One worker paints a line so that the measure of angle 1 is 65 degrees. The other worker paints a line so that the measure of angle 2 is 65 degrees. Are the lines parallel? So if we know that the measure of angle 1 right here is 65 degrees, and we know the measure of angle 2 is 65 degrees, are the lines parallel? And you have to explain. So here's what you'd have to write. Yes, they are parallel. Why? Because angle 1 and angle 2 are alternate exterior angles. And if alternate exterior angles are congruent, then the lines are parallel. So keep in mind that what you just used is the converse of the alternate exterior angles theorem. So at the bottom of page 674, let's look at the got it problem in problem 4. It says that you can use algebra along with postulates and theorems from the last lesson and this lesson to help you solve problems involving parallel lines. So in problem 4 under the got it, it says, what is the value of W for which C and D are parallel? So it's telling you line C and line D are parallel. So because they're parallel, what do we know about corresponding angles? We know they're congruent. So you can say 3W minus 2 equals 55 degrees. That gives us 3W equals 57 degrees. We divide by 3, and the value of W would be 19. And that's it for this section, 11.3. You do not have any new vocab words. You do have, however, 4 theorems that you need to know how to use. The converse of corresponding angles theorem, converse of alternate interior angles theorem, converse of the same side interior angles theorem, converse of the alternate exterior angles theorem.